Alright, so this question is from NCRT exemplar, and the focus of the question is to calculate the back EMF in a solenoid. What you're given is three sections, okay, and the magnetic field inside the solenoid is constant, and you can see it is mu naught Ni, where n, small n, is the number of turns per unit length. So this is the solenoid, and you are changing the current. So you can see there are three sections. One is the OA, then AB, and then BC. Okay, what you're given probably is the EMF which is existing in the solenoid in one of the sections as E. Now you know the flux is given by B dot A, and magnetic field in a solenoid is known to us, right? It's mu naught Ni. Take derivative of both the sides, and you know the medium does not change. What changes in these scenario is the rate of change of current. So di by dt into A, right? So the rate of change of current, which is what this graph represents. All the lines in this graph are the slopes which represent change of current with time, right? And we are given one of the slopes in the question, which we will use to our advantage. So now we know the source of back EMF is di by dt. Area does not change, right? So yes, so di by dt is your EMF which we are referring to. I hope this is clear to you. So this is the most important concept in the case of the EMF generated in the coil of the solenoid itself. Okay, now let's go back to the question and see what are the values which are given to us. We know we can find the slope of each of the line, right? We can find the slope of OA, AB, and BC, and use these slopes to calculate the back EMF in each of the unknown parts of the graph. Because in every part of the graph, if you see, there is a di by dt happening, but the slope is different. Okay, now if you notice, the maximum EMF means that the rate of change of current is maximum, right? If you can see the slopes, the maximum slope is occurring in AB, right? In the smallest amount of time, maximum amount of current is changing from 5 to 10. Okay, you can see AB, the current is starting from 1 amperes and then reaching -2, and it is just taking 5 seconds for this 3 ampere, which is quite big change happening in a very small time interval of 5 seconds. If you notice OA, the EMF is, the current is changing to 1 ampere in 1 second, right? Slope is low. And in the third section BC, the rate of change of current is very slow. It is taking around say roughly around it's taking around 20 seconds to change the current from 1 ampere to 0 amperes, right? So the slope in the third part of the graph is also very low. So AB represents the highest EMF because di by dt is highest in this section. Alright, now we have been given the EMF in one of the sections as E, and let's use that to calculate the EMF which is getting generated in other two parts of the graph. And all of this is going to happen from ratio proportion, because EMF is only directly proportional to di by dt, which is the source of EMF. Mu naught is not changing, N is not changing, A is not changing. So the only dependence of EMF is on di by dt. So use di by dt and EMF as the two variables which are directly proportional to each other, and with the help of ratio proportion we will calculate the EMF So if you notice AB, the you can see the in AB the change of so the change of current in AB you can see is available to us, which is 3 amperes, and we know the time it takes to change this current, right? So we know the di by dt that exists in AB. We also know the di by dt in the first part, OA. It is given to us, right? So with the help of the slope available in OA, we will calculate the EMF in AB, right? Two slopes are known to us. One EMF is known. So we can easily calculate the slope in AB, which helps us to find the EMF during AB. Okay, so it's just ratio proportion you're doing. You can see the slope of AB is 3 times the slope of OA, and therefore the EMF which is generated is 3 times as compared to AB. You can see the direction is reversed because instead of increasing current in AB, the current in the second section BA is decreasing. Alright, and hence you see the negative sign in case of BA. Okay, so I hope it is cleared in your mind that the concept is the rate of change of current has to be found out and is proportional to the EMF associated with it. Now let's go to the section last part of the question, which is you have to find the EMF in BC, right? If you notice BC, the current is increasing now, and you can see the current is rising from 2 amperes to 0, right? So there is a decrease in current, but it is -2 to 0. So you can write this as 0 minus -2. So 2 amperes is gain of current in the last 20 seconds of this, right? It's because it is starting from 10 and ending at 30. So the rate of change of current is 1 by 10, 2 by 10, right? It should be, and you can use the magnitude because it's -2 to 0, right? So 0 minus -2, that will be better if you can write 1 by 10. So EMF is going to be proportional to how much? 1 by 10, right? And we know the EMF during the first section is proportional to 1 by 5. So this time the EMF is going to be half of the EMF of AB. So it's just basically nothing but ratio and proportion. Okay, since your EMF has the rate of change of current is half of AB, the EMF produced in the section BC will be half of what is produced in AB. So you can write it as E by 2 directly also. I hope this is making sense to you, that a lot of dependence is on di by dt value. Otherwise the question is very straightforward in doing. So this is a direct application of a solenoid which is demonstrating EMF in its own coil because of change in current through it. Okay, so this is a solenoid and it is showing you EMF due to di by dt. That's a main thing you have to understand about solenoid. You can practice some of the questions and see if you have learned the concept. There are many videos available in my channel on toroid and solenoid. Solenoid is very important for JEE mains and board examination. So I hope you like this. If you do, please do subscribe. Thank you very much.